Hello guys, my name is Sandip and today we are going to start a new chapter. Right? Chapter is bit of body, normal reaction and tension and friction, right? There should be commas here. Let me mark the commas. Right? So there are different forces actually, right? So we are dealing with the forces here. Weight of the body. Weight of the body means what? Right? Consider if somebody asks you, what is your weight, right? Normally what you do, there is a balance. We can see the balance at the doctors, right? Doctors hospital, we can say, right? When you go to the doctor asks you to do weight, right? And you take the weight on you, right? We just you just stand on that balance, we can say, and it shows you some weight, maybe 40 kg, 50 kg, or etc., etc. Right? So when we say weight of the body, okay, so simple meaning of that, it's mass into G. Remember, whenever we are measuring or doctor is measuring our weight, that is not actually our weight. That is actually our mass. So 40 kg or 50 kg. Let's say 40 kg mass, right? So 40 kg is a mass, not a weight. So what is weight? Weight, we can say it is nothing but M into G. So anybody can recall what is G? G is nothing but acceleration due to gravity. With that much of acceleration, Earth is going to pull every object, right? We know that Earth is very, very big object, and obviously it is attracting, it is pulling every object on the surface, even us, right? We cannot go, we cannot just jump in the high in the air, right? What we have to do? Earth is going to attract us, right? With what force? That force is actually called as the weight of the body, right? Simple. Then consider normal reaction. Normal reaction means what? We will see that one. What is tension? Tension means not our tension of the studies, okay? So tension is another force. What is friction? You must have heard friction somewhere, right? So tell me one thing. Consider, um, let's say your cycle or bike or even our slippers or shoes, we can say, right? We have to change those slippers or shoes. Even for the bikes or cycles tire, you can say we have to change that after some years, right? So why we have to change those things, right? Can anybody think on that? Why we have to change the sandals, our slippers? Yes, that's right, because the sole of that sandal, sole means the downward part, right, gets very smooth, right? So after some years, we can say there is a possibility that you will sleep on the floor if that part sole becomes very, that is called as sole, right? That sole becomes very slippery, you can say, right? When you buy the new sandal or new sleeper, that sole, you can see it is nothing, it is little bit of rough, there is a rough linings there, right? But after some years, let's say 1 year or 2 years, right, what happens, that become that roughness is gone, only you can say slippery part remaining there, right? So smoothness is there. So why that happens? Because we use that sandal. We use that sandal on what? Obviously on ground, we can say on earth when we are walking, right? So this friction force, this friction is the force which is going to cause that, smoothness of that sole of our sandal. Okay, similar things we can also say about for our bicycle or bike or car you have, right? For the tires are also made out of rubber, right? So those are also going to get slippery after some years. So obviously we have to change those two. So that that friction, we can say, it is the cause of that thing. Okay. So let's see what is there in this chapter. So now what here I can see some spring here, right? And one block. You must have seen this type of springs many times, right? Even in case of considering your, if you have the ball pen, if you just open that, you will also find a very small spring there, right? That spring is, we can see in this diagram, it can extend like this. Spring can extend like this, right? So blocks are getting down and the spring has some extension there. Also it is getting compressed. You can observe that, you can do that practically, right? And take the spring out of that ball pen, you can extend this, elongate it, or you can compress it, right? Just press it from both the sides, right? Here same thing is happening here. Big spring they have taken and block is attached to this one, right? What is happening? That spring is elongating, compressing. This keeps continuing, right? Okay. So who is responsible for that? Again, there must be some force acting on that, right? That block must act some force on the spring, as well as spring is also coming upward, right? So can I say, right? Think on this one now. Can I say spring also applies some force, some kind of force there? Yes, it should, right? Okay. So we are also going to talk about that one, okay? So these are the forces, different types of forces we have seen, right? As our chapter's name suggests, first one is weight. Then we have normal reaction. What is normal reaction? That way we are going to see that, right? Then tension. Tension is the force in the string, right? So also you must have seen some in movies, maybe, right? There is a well of the water, and people are going there to take the water from that well. What they do, there is some pulley, you know the pulley, right? That is some kind of wheel, and the string is connected, rope is connected along that pulley, right? And people try to pull that rope, right? And because of that pulley, that rope is going to get some water in the bucket, right? Obviously the bucket is connected to the rope, we can say. Okay, so there is rope. Wherever there is a rope or string, we can say, right? That is the case of the tension force, right? We are also going to see that tension force too, so that's not a problem. Then friction we talked about already, right? Little bit. So we are going to see this all things in detail. Okay, so which topics we should cover here in this session? We are going to start with the definition of force and what are the different categories of force. We will see those things. Okay. So, so before moving forward, let's take one example here. Consider your family, whole family, your mummy, papa, your brother, all are going on a trip. Let's consider you are going on a trip. You have a very nice car. Consider, let's say this is the car. Right? You're going in this car like this. Right? Now, just assume after some times car breaks down. What I'm saying, after some times car breakdowns. What will happen? Right? Your father will say that go outside and try pushing the car, right? We have to take that car up to the garage now. Right? Obviously, father cannot come to push down because someone needs to be there on the steering wheel, right? Okay. So now your brother, let's say, comes from this side and started pushing the car, right? But obviously his car is very heavy, so you also need to go out and help him, right? So now, as your father said, go and push the car. What you did, you came, let's say, from another side, let's say this side, and started pushing car from this side, right? What will happen in this case? Your brother are applying the forces, right? Will the car move? No, right? So what will happen? One thing is very sure, that your father will be very angry at you. Why? Because you are pushing this car from the other direction. You should push the car from backside, right? So you are supposed to help your brother, not oppose his force. So doesn't matter whether if you're pushing, but also one more important thing is what is the direction of your force, whatever force you're applying, right? So what I can say in this case, force is nothing but push. Can I say it is push? That's right. Magnitude is important. Obviously, you will have to push it very hard, very with a big force. You have to apply a lot of energies for that. Then it will try to move, right? So it is dependent on direct magnitude. I can say how much force, that is called as magnitude, and other part is a direction. So direction means in which direction you are pushing. It is also important. Initially, you were started pushing from the front side. That didn't work, right? So and you came back to your back of the car, and now it is going to apply same force, or we can say same direction, right? So now let's consider another case. As the car is very heavy, you two are not successful to push it, right? So what you will do, obviously we need to take that car to the garage, right? So you are going to call toll truck. Toll truck means what? Toll truck is a big truck, obviously something like this. Big truck which is going to tie a string, let's say one string rope, we can say, right? We talked about the rope, right? There is which force is there? Tension force is there in the rope, right? Now this rope is going to, or we can say this toll truck, this is called as toll truck. This toll truck is going to carry your car up to the garage, we can say, right? Now you can go and sit down in the car, right? You don't have to be at the back, right? So you are pushing, right? Pushing means applying the force. Obviously that force was not enough, therefore we required the toll truck, right? But you're pushing, right? So you're pushing means you are applying some force, obviously. So I can say push is a force. What this toll truck is doing, is it pushing the car? No, then it is pulling the car, right? So can I define the force, that force is nothing but push or pull by one object on the other object. Very simple. There is two objects are there. You were pushing. In that case, you were the object, and car is another object, right? So force could be push or pull. Who is pulling? Toll truck. One object is pulling, other object is getting pulled, right? Force is push or pull, right? So there is a very simple definition we can do for the force. Okay. Now consider. Now we know this thing, right? This person. Who is this person? Right, if you do remember, this is the person which is responsible which is responsible for many physical research, we can say physics research, right? Many experiment he has done, right? You see, it's Isaac Newton, right? So here actually these are two different things, don't get confused. He is not throwing an apple on his head, right? Let's segregate those things, right? So when the apple falls on his head, right, he started studying why the apple is falling downward. If apple falls on our head, we don't do that, right? We will just eat it. But Newton was different. Newton said, why that apple just fell downward? Why it doesn't went upward, right? So after that, he did a lot of research on that, and he found out the one force is there, which is called as gravitational force, right? So this is the gravitational force, and this person is throwing apple, right? Also, he is also applying some force, we can say there, right? Okay. So this is Isaac Newton. Remember this person, this scientist. We are going to study him for almost now. I don't know, up to level you are going to learn physics. There will be Newton, right? Okay. So now, as we said, Newton told us there is one force which is called as gravitation force, right? So let's say there is a gravitation force, gravitational force. This is our important. Newton obviously gave us one formula also, which is called as G m1 m2 upon r square. Let's take a small look on this. M1 means, let's say, any object is here, M2 is another object is here, let's say, and the distance between them is, let's say, R. Okay, so if this is the distance, we can find out the force of attraction between these two objects. Now here in this case, is there attraction between Apple and Newton? No. Apple and Earth, we can say, right? There is attraction between Apple and Earth. Earth is attracting that Apple with some gravitational force. Newton was just in between the Apple and Earth, we can say. Therefore, Apple struck to his head. Okay. So this is one formula, one force we can say, gravitational force. Then we also have second formula. Second formula is, let's say, electromagnetic force. Electromagnetic force. Obviously, we can see there is a electric term is also there, magnetic term is also there. We have studied both the things, right? So electric means, can we say electrostatics? There are charges, proton, neutron. We have studied those things. Electron is revolving around the nucleus, right? And magnetic also, we also know the magnetic. We have done the magnetic force, not magnetic force actually, but we have studied about some magnets in fun with magnets chapter, right? So that magnetic force is also there. Obviously, if you do remember, we said there is a property when the unlike poles kept close to each other. What they are going to do? They are going to attract each other. Or if the north is there, south is there, means like poles are kept near each other, what they are going to do? They are going to repel each other. Right? So this repulsion or attraction, is anybody pulling them together? No, we are not pulling or pushing them apart, right? So there must be one force between them that is called as magnetic force. Even we can say in proton and electron. Electron is revolving around that nucleus. Who is making it possible? There is electrostatic force. So these are the types of, we can say, electromagnetic forces. Okay. Then we also have one more force which is called as strong nuclear force. Strong nuclear force. This force, obviously, as the name suggests, we can say it is in nucleus. Nucleus of the atom, we have studied that one also, right? In nucleus, we know there are protons and neutrons, right? So protons and neutrons are there. Proton has which charge? Proton has positive charge. What about neutron? Neutron do not have any charge. Those are neutral, right? And we also know that the electrons are revolving around these things. This nucleus, we can say, let's say in circular orbit, right? So let's say electrons are here, they are moving, and electrons have negative charge. That also means. So nuclear means it is only related to nucleus, right? Electron proton will have electrostatic. Electrostatic is the type of electromagnetic, right? Nuclear force means, again, it is the forces between, we can say, proton proton or proton neutron, right? And next one is a weak nuclear force. Nuclear force, right? Again, it is related to nuclear force, right? So these are the four different forces which are called as a fundamental forces. So whatever other forces, right, we have seen that weight, tension, friction, those are nothing but the types of all these four forces, we can say. So these are the four very important forces on which nowadays scientists are studying on, right? Okay. Then very important thing in this four forces, which will be the strongest force here? Can I say strong nuclear force will be the strongest force? Yes, it is a strong nuclear force. What about the which one is the weakest nuclear force? Now we may get confused here that because the weak name is there in the weak nuclear force, but it is not the weakest. Weakest force is gravitational force, right? So in future you are going to encounter with this question, right? Which force is the weakest force? Remember, gravitational force is the weakest force, right? Okay. So you may ask why? Because Earth is attracting the apple, right? Earth is not letting us go, letting us jump very high. Earth is always attracting us. It has some force, right? Then how it could be weakest, right? Because Earth is a very, very big object. Therefore, Earth can attract. But now you can consider any two objects. Suppose we have here, let's say your laptop is kept here, or mobile is kept here, and let's say your notebook is here, which is very closer, right? But are they getting attracted towards themselves? No. Why not? Because this gravitational force is very, very weak. This is the reason they are not getting attracted towards each other, right? Okay, so remember this part very carefully, right? As I said, in future, you are going to encounter with this question, which one is the biggest force? Okay. So now let's move to the next part. Definition of force, right? We have already seen this part, right? Pushing, you and your brother were pushing the car, right? Or we can say tow truck was pulling the car, right? So force could be push or pull, right? Here also we can see example. The first person is pushing this block, right? It's, I think, looking at him, it is very weak, right? I guess. And this block must be very heavy. Similarly, for second person also we can see he is pulling someone. Okay, there is some one there, right? Let's see. Yeah, I think it's big dog. He's pulling that big dog. He was not able to, right? Obviously, we'll need to apply a lot of force on that. Also, there is one more case. Is there's string here, string, right? So if you want to pull object, mostly we are going to use the string. And wherever there is a string, there will be tension, right? We know this thing now. Tension is what? Not our studies tension. It is the tension, the force. Okay. Now, for the definition of force, we have already defined the force in the previous slide, that force is pull. It could be pull or it could be push, right? On one object by the another, right? Force is pull or push on one object by the another. So this is a very simple and short definition we can say of the force. Okay. Now let's move to the next one. As we know that what force can do, force can actually push or pull, right? There are other things also force can do. Here we can see one thing there, right? Using the force, consider this the football, right? Football is not very heavy, we can say, right? Or not very rigid. So football is soft like this one. So I'm not saying that you can totally, we can say, make it flat. You cannot make it flat, but you can observe that you can change the shape of the ball. Something like this. Like this kid is changing the shape of the ball, right? So what he is doing? He's applying the force. Is he pushing or pulling? Yes, it must be push, or there must be push or pull. As we know, the force is nothing but push or pull, right? So obviously it's pushing there, right? He is changing the object shape of the object. Yes, he is changing. So what force can do? Force can change the shape, we can say. What else force can do? Let's point this out. So first, as we can see, force can change the shape. Right? Can I also say force can change the speed? Right? It can change the speed, right? If in our case, so your brother and you are pushing the car, right? You were not able to, but must have applied some force and some speed must have changed, right? It must have started rolling down, or we can say started in motion, right? So if you apply obviously more force, like the tow truck was pulling the force, means car was at rest initially. Now it has the change of the speed, we can say, right? Then can we say force can stop moving object? Stop moving object. Is it right? Can force stop moving object? right? Obviously, consider the football game or even cricket game, right? What happens in cricket? The batsman hit the ball. Obviously, he applies some force on that. What does the fielder does? Fielder do? Fielder actually stops the ball, either catches the ball or just stops the ball, right? So he stops the ball means what? He also applies some force. So batsman is applying force to move the object, we can say, right? And so here we can say it can change the speed or also start moving the object, right? And fielder is doing what? Fielder is stopping the object, right? The object which were already moving. Similarly, in case of football also we can say, what is the role of goalkeeper, right? You have to stop that ball from going into the goal post, right? So he's going to apply some force to stop that ball, right? So force can change shape, force can change speed, force can start moving, start object. Let's write this as start motion of the object. And we have also seen it can also stop moving the object. What else the force can do? Force, can I say force can also change the direction? Yeah. Again, we can take the same example, right? Let's say cricket. In cricket, what happens? Bowler is actually throwing the ball towards what? Towards whom? Towards the batsman. So it is going in a straight line. That's right. What a batsman is doing? Batsman is applying the force in other direction, right? So obviously, it is changing the direction. So let's say force can change the direction of what? Direction of motion. Let's say direction of motion of object. Simple. So these are the different things force can do, right? What else do we know anything which force can do? Right. So I think those are enough, right? Okay. So now let's move to the next part. So now we are going to categorize the forces, right? So there are mainly two types, we can say. Two categories are there. First one we are going to call it as a contact force, and let's call another one as a non-contact force. Now, as the name suggests, it is very easy to understand, right? Contact and non-contact. Contact means what? There must be contact between the two objects, right? Which are involved, obviously, right? So let's come back to our original example. When you and your brother were pushing the car, what is going to happen? Can you just put your hand like this and it is going to get pushed in any way? It is not going to happen, right? We are not Superman, right? So we have to actually touch that car also, right? So if you want to touch that car, obviously there is a contact. If there is a contact and we say it is a contact force, yes, what were you doing? You were pushing that car. So can I say this pushing force is a contact force? That's right. So here in this case, this block is kept on, let's say, table. If you apply some force on it, that is called as pushing force. That block will get some motion there, right? And yes, that is called as contact force. Simple. Then, what are the other types of the contact force? Can we say this friction? Friction, yes, friction is also there. When friction occurs only when any object is, we can say, moving, or it could be at rest, but it should have some contact with the surface, we can say. Then only we can get the friction. So yes, friction force is also contact force. Then in gym, you must have seen this dumbbells, right? Uh, Weight, he is lifting the weight, right? This person is lifting the weight with some force. Which force is there, right? Can I say it is a muscular force? Yes, it is a muscular force, right? It is also the contact force, we can say. So there are different types of the contact force. Let's list out some of those types, right? Friction, right? So what is friction? Can I say the object is kept like this, right? Normally what happens, we are going to see this in detail, but just now consider if you apply some force here, what is going to happen? Frictional force will get created on the opposite side, right? So remember, friction force always gets applied in the, or induced we can say, in the opposite side of the external force, and obviously this frictional force is our contact force. Then there is another force which is called, as we have seen, pushing force. Yes, pushing force is a contact force, right? We have seen this example, right? You and your brother were pushing the car, right? What are the other types? Can I say tension? Is tension pulling or pushing? Tension pulling force, right? But pulling force, is there a contact between those? Obviously, again we have taken the example that toll truck was carrying, pulling your car, right? That is also obviously the pulling force, tension force we can say, and obviously it is the contact force, right? You can also consider this example. What is this thing is called? There is one string and one sphere, one small sphere is connected. The sphere is called as bob, right? And this thing is called as simple pendulum. Simple pendulum. So it is going to rotate like this, right? It could go up to here and it will again come back up to here. Right? So tension is where, I told you, wherever there is a string, wherever there is a rope, there will be tension. So I can say this, I can mark this as tension force. Tension force is represented by capital D. Friction force is represented by, let's say, Fr. Okay, so these are the symbols for the forces, right? Then also there is a normal force also in our chapter's name. There is normal forces there, right? No, let's see what is a normal force now. Now consider any object is kept here, right? So what are the different forces acting on this object? First of all, for any object, we already know that Earth is going to attract that object, right? With force, which is called as weight. We normally call it as weight. I told you that when we measure our weight in on the balance at the doctor's place, that is not actually our weight, right? That is actually our mass. Weight is the force with which Earth is going to attract us. Right? For this block also, which is, let's say, kept on this table, Earth is going to attract it anyway, right? What are the other forces there? Is there friction? No, we are not applying any external force, so there is no friction, right? But there is one another force there, right? Not mg, obviously. Mg is the Earth's force, but as this block is in the contact with the table, I can say this block is in contact with the table. So can I say that table is also pushing the block upward? Obviously, right? We cannot see that. Obviously, if our laptop is kept on the table, we cannot see that table is pushing. But yes, it is. There is a contact. So remember, table is pushing any surface on which any object is kept, right? That surface is going to push that object with some force. That force is called as normal force. Remember this part. So this is our, let's say, fourth type of the contact force, which is represented by En. En is our normal force. Okay. So these are the different force which obviously requires contact between the objects. Here you can see that in every case there are at least two objects are there, right? In friction case, table as well as block is there. In normal case also, table as well as block is there. In car's case, one object is car and another object is you. You can see you are pushing that car, right? And in tension's case, string is pulling what? String is pulling that bob, we can say, right? So string is pulling that bob. There is a contact in between them. So all these are the different types of the contact forces. Okay, so I think it is clear now that what is the contact force. Okay, so now let's move to the non-contact forces. Yes, can anybody guess what will be the non-contact force? Any example? I also mentioned that example many times in this session also. right? Yes, that is gravitational force. Gravitational force is a non-contact force. Means in the first case, when the apple falls on the Newton's head, apple was on the tree, right? Who is attracting it? Earth. Is there a contact between earth and apple? There is no contact. Still earth managed to apply some force on that, right? So what we can say, there is no contact, still gravitational force is there, and gravitational force is a non-contact force. Now let's see. So these are the non-contact force. You can see some examples also here, right? What is happening in this case? Who is this cartoon? I don't know the name. It looks something, it's not Tom, I know that, right? Looney Tunes, I guess. So I don't know his name, but he's pulling that tin, we can say TNT. TNT means use explosives actually, right? That TNT is pulling with that magnet, right? This is what this magnet. We have seen that magnet, right? That is our horseshoe magnet. We know that, right? So it's pulling that we can say with that magnet. Magnet is applying what? Magnetic force, right? It has magnetic field also, right? You can see they have also shown some lines. We have seen some lines yesterday. Tell me, are they correct or wrong? Right? Those lines are not our magnetic field, right? They are actually showing that it is attractive force is there, right? So obviously magnet is going to attract which part? Magnetic parts only, not non-magnetic. So only iron, cobalt, nickel, we can say it can attract. But can you see initially in that case, is there a contact between that magnet and that TNT can? No, right? So this is called as a non-magnet, non-contact force. So there is no contact, still that magnet was able to attract that can. Okay. So we can say this is our first type, that is magnetic force. And in the second example, obviously we have talked a lot about this one. This is the earth and person. Now, obviously, if you comparatively that image is not very accurate, right? Person cannot be that big, right? Height will be very small compared to Earth. Right? But just for the illustration they have shown, right? The arrow is there. Arrow is where? Toward the center of the Earth. Means what? Earth is going to attract any object towards the center of the Earth. Obviously, it is not possible that we will go into the ground, right? But we're staying on the surface there. Even for the case of apple, apple was on the tree. So consider if this is the tree, like this, and apple was here, right? So what Earth is doing? Earth is actually trying to attract this apple toward the center. As we know, it will only stop on the surface of the Earth. It will not go toward the center. And as Newton was in between those, so it fall on the Newton's head, and therefore we have to study a lot of physics, right? That's right. So this is a gravitational field, gravitational force, we can say. What is the important thing we should know about this gravitational force? I told you at the start only. This gravitational force is the weakest force found in the nature, or whatever fundamental forces are there. Okay. Then third force. Can you tell me which is the third force? Right. Look closely what it is. There I can see one comb is there. Right. If you can try to zoom it, you can zoom it. You can try that one. Right. This part is a comb, right, which you use for our hairs, right, set our hairs. And these are the pieces, small pieces of the paper, right? I know that you must have done this experiment, right? This is related to our electrostatics. We have also seen this one, right? What I have to do, we also seen one video for this, right? So rub this comb on your hairs, we can say, and what is going to happen? It is going to attract some small pieces of hair, right? So initially there was no contact between comb and pieces of the paper, but still it can attract those pieces, right? How? Obviously there must be some force which is called as electrostatic force. The electrostatic force is getting applied there. So and also there is no contact. So can I say electrostatic force is also our non-contact force? Obviously, right? Protons are in nucleus, electrons are revolving around it. So obviously those are also our non-contact forces. Okay. Sure. So these are the different types of the forces: contact forces and non-contact forces. Let's move next. Okay. So this is the whole theory part of our this session, we can say. So what we have studied, we have started with the concept which is force, right? Or force, that is our first question. That is define force. Define force means it. We have already seen that. What is the definition of force? Either it could be a push, it could be a pull, right? So push or pull, we can say it is the force, right? The force which push or pull, we can say. Let's write this definition again. So this is the favorite question of the examiners or paper sitters. I can say force is the push or pull applied by one object on another object, right? Simple, right? And it also has the direction. It also has the magnitude, right? We know that part too. And because we know that if you push from front, your brother push from behind, nothing is going to happen, right? Because direction is also important. You should also go to the back side and then try to push that car. So force also has magnitude. Force also has direction. We also have seen some properties of the force. What force can do? It can change the shape. It can stop the motion. It can start the motion. Also, it can change the direction also, right? So these are the different things force can do. We also seen that part. Okay. So let's move to the next part. What is contact force and what is non-contact force? What we can say about the contact force? These are the forces which are let's mark contact force. You can write this as contact force. The force between two objects which are in contact. We have also seen the examples, right? That's right. Then if you wrote this definition, I don't think non-contact force is very difficult to write, right? What we can say, non-contact force are those forces which are in between two objects where there is a no contact in between them, right? Very simple. Then let's see, state whether the following is true or false. So first they are saying friction is a self-adjusting force, right? Now we haven't talked about this, but I have mentioned one thing. If you do remember, I told you you apply the force here, frictional force acts on this side, right? Let's take another case. If you apply the force on this side, frictional force is going to go on this side. So we are not applying the frictional force. We are applying this external force. This EF and EF both are called as external forces. These are external forces, right? So if we can apply the external force, but friction gets generated itself. Therefore, it adjusts itself. Simple thing, right? It adjusts itself. Therefore, we can say it is a self-adjusting force. Okay. So obviously, this part is true. Then second is a normal is non-contact force. Now, if you remember what is normal, right? If the block is kept on table, for example, your laptop or any book or any mobile is kept on the table, we know that even we cannot see it, but table is going to push that object, right? With which force? With the force which is called as normal. We are going to study this in detail in the next session, right? So this is the normal force, and obviously, is there a contact in between those? Yes, that's right. So normal is a contact force. So they have written it is non-contact. So we have to say this is not true. This is false statement. Then normal always acts upward. Yes, here we can see that normal is acting upward, right? If any object is kept on the table, it is acting upward. But also remember one thing, consider if this is the inclined plane is there. Inclined plane means must have seen this, let's say in rails or steps, we can say steps are somehow inclined, right? It's smooth step we can say, not all the steps, but only one smooth step we can say. Right? So there is some, it is making some angle theta we can say with normal. For this, normal is not upward. Normal is like this. Okay. So don't worry, we are also going to study this one also in the next session. So normal always acts upward, it is also false. Normal can act like this also. It is not necessary that it is always upward. Okay. So there's some question. Let's move to the next one. Yeah. Then force can change. Yes, these are some properties we have studied for the force. Yes, which one should be the answer? Shape, direction, or speed? All of those, right? So our answer should be D. Force can change everything. Shape, direction, as well as speed. Okay. Then which of the following is a contact force? Now we already know which are the contact forces, right? And non-contact. So yes, try to remember those. Gravitational, is there any contact between object when the gravitational force is applied? No, right? So gravitational force is not a contact force. There is no contact required. What about the electrostatic force? Protons and electrons have the electrostatic force. We can say electrons are moving around proton. There is no contact. So electrostatic is also non-contact. What about tension? Tension, when remember, whenever there is a string or rope, we can say there is a tension, right? So yes, we can say tension is a contact force. Last one is a magnetic. We have seen that small animation there, right? That cartoon was actually attracting that TNT explosive, right? So that is also non-contact force. Okay. So these are the questions from the session which could be which could occur in your exams, right? So this is our the introduction type session. We can say about the different forces. What we have seen the four fundamental forces, right? Anybody remember those? First one is gravitation. Then we have electromagnetic force. Then we have third strong nuclear force. Fourth, weak nuclear force, right? Those are the different forces. Definition is also important, right? Newton, as I said, Newton is also important for us now. Okay. Then we have seen the our categories: contact forces and non-contact forces. What are the contact forces? What are the non-contact forces? Now we know that part too. Okay. So we have just taken some introductory part. Now in next session, what we are going to do? We are going to study these forces in detail and what they actually do. Right. That is also important part. Okay. So what are the weight? What is weight? As I said, that mass is not weight, right? Mass is different quantity, weight is different quantity. When we say our mass, our weight is 40 kg, we are not, our weight is not 40 kg, it is of mass is 40 kg. So how much is the weight? We will study that too, right? Then normal, as we have seen one twist there in our one of the example, that normal is not always upward, right? Why it is not upward? We'll see that part too. Okay. So we are going to study this forces a little bit in detail in the next session. So for now, we are going to stop. Okay. So if you do have any queries, please post them in forum so I can answer them. Okay. Sure. So I hope you enjoyed the lecture and we'll stop here today. Thank you very much. Have a nice day.